What's up, everybody? Quick quiz review for you, and hopefully you had a chance to go through the entire thing. Quick one, not too many questions on there, and hopefully you can check yours, make sure you got them all right. But if there's one you got stuck on, that's what I would recommend, scrolling to the one you got stuck on and not worrying too much about the rest here. So if you already know how to do it, just move on. So, all right, let's run through this real quick. I'll go as quickly as I can. Number one, okay, you got a small pyramid in the surface area. Okay, that's kind of the thing to identify here. Surface area is 98. Now, I don't know anything about the dimensions of the other parts of this. I don't need to know it because all I'm doing is doing 98. And you could do this as a proportion if you want. So you could say like the smaller surface area is to the larger surface area. We'll say that is X, the thing you're trying to find. What's the surface area of the larger pyramid? So 98 is to X, just like, and then you're just going to compare the sides, like 7 is to 15. Uh-oh, but wait, it's area. And when you see the word area, when you're comparing similar figures or whatever, you need to square the scale factor. Okay, let me just pause for a second. You square your scale factor. 7 is to 15, that's just the side. When you're talking about the square footage or area or whatever, you got to square that scale factor before you use it. Okay. Similarly, if it was asking for volume here, you'd have to cube that scale factor. But in this case, we're just going to square 7, and then 98 times, let's see, 225, and then divide that by 49 should get us there, 450. Okay. Now I encourage you to cross multiply and do all the things I was just sort of walking through as quickly as I could, but just set it up and cross, multiply, and solve. Here we go. Salt shaker is shaped like a cone. Number 2. If the height of the salt shaker excuse me, is 5, so the height is 5. All right, that's given to us. What's the volume of the salt in the shaker? Okay, so we're really trying to find this volume of this space in here. This is a frustum. Okay, I've never seen a salt shaker shaped like that, but you never know. So let's write the formula. V equals, now most volume formulas are base times height, right? Big base, area of the base times the height. But it comes to a point, so it's 1/3 base times height. So this is the thing. I don't memorize formulas. I memorize concepts and then apply it to the formulas. So normally it's base times height. And so I'm going to go 1/3 height times base. Now instead of base, I think of what the base is for this formula. Ready? It's base 1 plus, and then I put base 2 over here at the end. And in the middle, geometric mean of base 1 and base 2. If you don't remember geometric mean, that's the square root of the product, okay? So normally for a mean, you would add them and divide by 2, but a geometric mean, you multiply them and square root them, okay? All right, and now we'll just plug in some values and see if we have what we need. All right, we got 1/3, that's given. Our height of the frustum itself is 5, so we'll put 5 in here. Our base 1, this is the area of the base, that's pi r squared. Well, pi r squared, that's 2, so pi r squared, the area, would equal 4 pi. So pi times the radius squared, so the area is 4 pi. And what's the area of this one up here? Well, if this is 2, and this whole height is 10, that means this little triangle here is half the size of that other triangle, which would make this a 1 right here. In other words, the area for this one is pi r squared, or pi times 1 squared. That's just pi. Okay? So now let's plug in those bases, those area bases, and see what we got. Base 1, I'm going to call 4 pi. Base 2 is 1 pi. And in the middle, I'll do 4 pi times 1 pi, okay, the geometric mean of those two things. Okay, it wants the answer to the nearest tenth, and when it asks me for the answer to the nearest tenth, I think your best bet is to use your calculator and just write it all in, because there's no variables there. I'll just do times 5 times, and then just type everything you wrote down. 4 pi plus the square root of 4 pi times pi. And the nice thing about doing it this way is you can go back and look and see if you did it right. You don't have to kind of backtrack and try to figure out what did you type where. It's all in one place. And close those parentheses. And as long as that matches, we should be good. And that's good. 36.7. Beautiful. Okay. All right. Moving along. Let's try this one. The height of a trapezoid is this. Oh man, this one sounds confusing. So I'm a picture drawing kind of guy. So let's draw this out and see what we get. Okay, this is the height of the trapezoid is the same length as its shorter base. So, trapezoids have two bases. Okay, so I'm going to draw the height of it. I'm just going to make it like this way. That would work. And is the same length as its shorter base. Okay, so it's kind of like this maybe, to make it a little shorter. And then we'll say we're going out here. The longer base is twice as long as the short base. Oh, well, that's easy to, right? It didn't say it had to be like isosceles, right? If the length of the shorter base is halved, the height stays the same, and the length of the longer base is doubled, what's the ratio of the the new area to the old area? Oh my. All right, so what we're going to want to do here, what I would recommend doing is, let's copy paste this, and let's make some adjustments, okay? And so let's repeat this, and let's do all the changes they recommended here. So let's see. If the length of the short base is halved, so let's just draw right over it. So this length is now half as long. Then what? The height stays the same. Good, so that's staying the same. And the length of the longer base is doubled. Ooh, let's see what that would do. We're going to double that. That's crazy. All right, and the height is the same. Okay, but now we're going to think about it in terms of the formula. What's the ratio of new to old? So let's look at that. Right, here we go. So ready? It's the ratio of the new to the old. So let's find the new area. Okay, so what's the area? Well, let's represent these with letters here. So this will be base 1. This will be base 2. This is height. Okay, now in terms of the other one, this would be base 1 over 2. This would be 2 base 2s. Okay, and the height would stay the same. Now we're going to compare the areas. So let's see, area new to the area old. The new area, that's the red one here, is going to be, well, the formula for the, let's do the old one first so you can see what the formula would look like. The area is base times, the average of the bases times the height. That's a good way to think about it. So I think base times height, but then I remember it's the average of those two bases because we got two of them. So B1 plus B2 divided by 2 times the height. Okay? Now over on this side, let's just put those new values in there. B1 over 2 plus 2B2 all over 2 times the height. Okay? All right, now it's just a matter of like working this out, okay? It's not totally an equation, but you can sort of treat it somewhat like an equation in that you have h on both sides, you can cross those out, okay? You're dividing by both sides by 2, so you can cancel those out as well. So now let's boil this down. B1 over 2 plus 2B2 is the same as B1 plus B2, okay? And now we could just simplify this a little further. Let's break this down. Did they relate the, let's see, the length of the shorter, yeah, so they don't, oh, yeah, the longer base is twice as long as the shorter base. Okay, so we're going to need that piece in there. B2 is equal to 2 B1s. I forgot that detail in there. And so if that's 2 B1s, this would actually be 4 B1s. Cool, let's write that out here. 4 B1s. Okay, so now I've got everything in terms of base 1. So let's sub those out real quick. It says that B2, I missed that detail, I'm sorry. B2, it says the length of the longer base is twice as long as the shorter base. So let's go ahead and put that in here. Okay, the length of the shorter base, all right, so we're going to plug in where I see B2, I'm going to put 2 B1s. So 2 times 2 B1s. So we say we had one too many variables here. B1 plus, and this is also 2B1. Okay? And now we can go ahead and clean this up, and let's solve it, and we'll get a ratio. Okay? So our goal is to get everything cleaned up. Let's do that. Let's get B1 plus two B1s is 3 B1s. And on this side, it'd be 4 B1s right here, and then a half a B1, so 4.5. So 4.5 B1s there. Okay? And now we'll just reduce this, maybe double both sides, so this would be, and then cancel out your B1s. So we'll cancel out B1s, then multiply both sides by 2. Okay, and the reason for that is I don't like that 0.5 in there. So this is doubled, and this is 9, and 9 to 6. I guess I could have done 2/3. We doubled both sides, and then, yeah, you can actually reduce that. And so it should be 3 to 2, and that's right. Okay, so a little bit of a longer way to go. I think I could have done this with numbers instead of letters, and that would have been helpful. So if you remember how we did this in class, I said, hey, let's just pick a value for this one, call it 1, and then this would actually be 2, that would be 1, that would be 1, that would be 1, that would be 2, and then you'd have half, and then this would be 4 down here, and that might have been a little easier to go. Okay, but either way, you're just looking for the ratio. It makes it pretty simple. I kind of went the long way with it. Sorry about that. All right, let's do this one real quick. This is an easy one. I think you'll like this one. This is a, let's get this out of here. This is a law of cosines. Okay, how do I know it's law of cosines? S, side angle, side. That's one of the cases. That's actually the easier of the two cases. You should be ready for both because it could be a side, side, side. So you got to be ready for both of them. But here's SAS in a nutshell. C squared equals A squared plus B squared. Okay, this is Pythagorean theorem. Then just do minus 2AB cosine C. I know Delta Math does it a different way in terms of the letters, like where they are. I ignore the letters on the triangle because they're not relevant. So I'm just going to go ahead and tell you that. Cross this off. Cross this off. I just make C the unknown. That's easier. Okay, so let's put C squared. That's the side we're trying to find. That's AC. Okay. I'll just write that AC squared equals A squared. Well, that'll be 10. Doesn't matter which one you pick. Squared plus 12 squared minus 2 times 10 times 12 cosine of 105. At that point, you go to Mr. Calculator, and you got 10 squared plus 12 squared minus 2 times 10 times 12 times cosine of 105. Okay, just hit enter, and then you'll be like, wait, that seems a little long. It's because you didn't take the square root yet. So do square root of that answer, and you get 17.5. Okay. All right. Fun, fun, fun. All right, here we go. 2 airplanes leave the airport at the same time. An airplane flies due east. So let's just draw a little diagram here. So we got one airplane going this way. The other plane goes east, northeast. So that's like, so northeast is like 45. That's half of 45. So it's going like this. And the question is, how far apart are they? Okay. So let's put all our values in here. It says the one that's flying east goes 300 miles an hour. But here's the catch. Ready? How far are they apart after 2 hours? So not right away, but after 2 hours. So that means total, this plane flew 600 miles. Okay. The other one flies 700 miles. So the question is, if this is 22.5 degrees, what's the distance from one airplane to the other? And again, if you said law of cosines, you'd be absolutely right, SAS. So it's going to be just like we did before, C squared equals, and then we've got 700 squared plus 600 squared minus 2 times A, so that's 2 times 700 times 600 cosine 22.5. There we go. Okay. And again, throw it in the calculator, let it do all the work for you. 700 squared plus 600 squared minus 2 times 700 times 600 cosine 22.5. And I got a huge number, which is way too big, but don't forget you got to take the square root here. So square root, and you get 271.9 miles away, or 272, I guess it would be more accurate. Okay, so hopefully that made sense to you. Let's go on. Number 6, the radius and the height of a cylinder are multiplied by 4. What would be the effect of the volume? Well, probably the easiest way to do this, I mean, you could kind of think this through here, and you're like, well, if you're factoring different things up by 4, you're essentially like scaling the entire thing by 4, which would increase the volume by 4 to the 3rd power. Okay, so 4 times 4 times 4, 64. So you just multiply describe that volume there. But it might be even easier just to do it because you can find this. So volume is base times height. So the base would be pi r squared. So v equals pi r squared h, in this case pi times the radius, which is 3 squared, times 6, and let's see what that is. Actually, I'm going to leave it in terms of pi so we can see the effects. Okay, so I've got 9 here, but 9 times 6 is 54, so 54 pi. Now we'll clearly see the effects of the scaling. The second one would, if after it's increased, multiply by 4, now you've got 12 in here. So this is going to be pi, and my radius is now 12. Okay, and then that's going to be cubed, or squared, excuse me. And then the height is going to be 6 times 4, so that's 24. And you could see, like, by putting a 12 here and squaring it, you're kind of multiplying a factor of 4 through this thing twice because it's squared, and then you're doing another factor of 4 there, so that's why it's 4 to the third power. And then we go, that's 144 times 24 is 3, 4, 5, 6 pi. And then you say to yourself, well, how do these two numbers compare? Well, you can divide them. And 3, 4, 5, 6 pi over 54 pi, that's going to equal 64, I bet you. Okay, so divided by 54, and we get 64, and happy birthday. This is what you're doing. Your volume increases by a factor of 64. Okay, it says find the perimeter of a circumscribed regular hexagon. Okay, I'm just going to sketch out part of this real quick so you can see. Now this is interesting because normally we have the circle around the shape. This time we have the shape around the circle. Okay, so just kind of keep an eye on that. I'm not going to draw the whole thing, but I'll get you enough where you can kind of see what's going on. Now what you want to do with this is draw in just one of these central angle triangles there, the equilateral triangle that would be on this. And because it's 60, that you know this angle is, or excuse me, because it's 360 here and there's 6 sides, divide that up and this is 60 degrees, which means half of it would be 30 degrees. Okay, it says that the circle has a radius of 20, so put 20 here, and now you've got a trig function. Okay, and now once you find that, you just multiply by 12, 2 to get each side, and then 6 again because there's 6 sides on the hexagon. Okay, so let's do that real quick. It's opposite over adjacent, so tan 30 equals x over 20. I put 20 degrees. It's not 20 degrees. It's just, oops, over 20. There we go. The length is 20. It's not 20 degrees. Apologize for that. And then just do 20 tan 30. So 20 tan 30. And I got 11.5. Okay, now that's the value of x. You also need to go through, of course, and find not just the value of that, but you need to multiply that by 12. So let's do times 12 because there are 12 half sides all the way around. So 2 x's per side, and there we go, 138.5, I guess would be the right, 138.6. Oops, pencil's bugging out, 138.6, and we're good to go. Okay, let's do a couple more here. It says find the value of x. Remember the formula, it's whole times the part equals whole times the part. So the whole thing times the part that sticks outside. Whole thing would be x plus 3, that's interesting. The part that sticks out is 3. And that's equal to the whole thing over here, which would be 8.4. And the part that sticks out is 2.5. And now you just got an easy little equation. This is 3x plus 9 equals, and then 8.4 times 2.5 is 21. Now subtract 9 from both sides, so that's 12 equals 3x, and x equals 4. And I think that's what they want. Yep, find x. Okay, so remember that whole thing times the part that's outside, okay, is equal to the whole thing times that little part outside. Okay, so just keep that in mind. All right, this is actually the same formula. If you know how to do the other one, this one's even easier. Whole thing, which is all of this, times the part that sticks out here, times the part, there it goes. So this is going to be 11 times 3. Be careful, because some of you will want to put 8 times 3. 11 times 3 equals the whole thing. Well, the whole thing is outside the circle, so that's just x times x again, or x squared. So here we go. This is 33 equals x squared. And let's take the square root of 33. And it's 5.7. Okay. To the nearest hundredth. 5.74, correction. All right, here we go. All right, last couple, and we're good. This looks like another one of these frustum problems. Okay, the Great Pyramid at Giza has a base blah, 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 blah. Who cares? It's given us everything we need. Just use the formula. So V equals 1. If you don't know how to do this, please reference the one I did, number 2, because it does frustum formula. All right, so this is height times base 1 plus, and then base 2 over here, and then the geometric mean in the middle. Oops, not times. There we go, times B2. Okay, and now we'll just throw down real quick. This is going to be, let's plug in the values. This is 1/3 times 75. That should make it easy. The area of my base one, it's a square pyramid, I believe it says. Cool, yeah. I should make sure I'm reading it right. And then this would be 230 squared plus the square root of 230 squared times 115 squared. And then plus 115 squared. Okay, and then this you can throw entirely in the calculator. So let's do that again, because they're so fun when you do that. 1/3, 75. And then we got 230 squared plus, right, it's 230, yeah, plus the square root of 230. Why would I put squared on there? I'm getting crazy here. I don't know why I'm putting squared on there. I have lost. Oh no! I did do it right. It's because we didn't make them squares yet. I'm sorry. I did put the squares on there for a reason, because it is. I haven't squared the area yet, so that is the area, 230 squared. So I don't even need to know what that is. It actually saves time to just leave the square in there, as long as you don't confuse yourself for a second, like I just did. All right, but we're good here. 115 squared, and that's just because that's what the area would be. And then the area of the base, again, is 115 squared. Not 115, but 115 squared. All right. And so this should be good. Let's see if we're right. And it's like a big number, 2.3 million. So that should be right. Okay. Big old volume. All right, last couple, and we're done. Let's go. Find the perimeter of the square that's inscribed in a circle of radius 2 centimeters. Okay, we're trying to find the perimeter of the square. All right, so to find the perimeter of the square, we just need one side of the square. Well, if you know what this shape is here, this is a 45, 45, 90, which would make this 2 rad 2. Now, if you're not sure about this, here's the formula. Ready? X rad 2, and boom. There's 2 rad 2, and now you just need to multiply that by 4. So this would be 8 rad 2, and 8 rad 2, I guess, do they want it in decimal? Let's find out what 8 rad 2 is. 11.3. Boom. All right. Last but least, it says regular hexagon is inscribed, blah, 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 blah. Don't use 3.14 for pi, because we have a better pi than that. Round your inch. Okay. It says find the area of the smaller circle. So we just need to find the area of the small circle. We need to, I feel like we've had one of these recently, but you need to draw this in here and then this in here. Okay. And make a little triangle here. We want to find R, because that's the radius of the smaller circle. And this is 17, this distance to the other one. Okay, notice you have a right triangle. 17 is now the hypotenuse. So the question is, what's this top angle up here? Well, it is a hexagon, and that's half of what would have been a nice equilateral triangle. So that would be a 30-degree angle up there. This is 30. Okay, now you're going to use your trigonometry, and we've got adjacent over hypotenuse. That sounds like cosine. So cosine of 30 equals adjacent, which is R, over hypotenuse, which is 17. And now we'll do 17 cosine 30. That'll get 14.72. equals r, and that's the radius. Now, is that the volume, or the, what does it want? The area of the smaller circle. Okay, so we're going to area of the smaller circle. That's just the radius, so pi r squared. So times this number squared. And I got 680.94. Okay, and now the book may say, or the answer key may have something different. That's because they use the wrong kind of pi. All right. Anyway, hope this is helpful, and let me know. Make sure you like and subscribe, all the things. I don't really care, actually. The only one I would maybe, put some numbers in there for number 3. I think that's going to be a lot easier than trying to manipulate the formula. Just make one up, make numbers that fit this. So pick a value and then just double it. I think that'd be easier to go. All right, guys, that's it from me. I hope you have a great weekend. Happy studying.